geometric sequences. So we looked at just your normal ones yesterday, and to be honest, a lot of the questions you will have, no, not a lot of them, what could be more similar to yesterday's, but I just want to draw these kinds of things to your attention. Certain questions don't necessarily say this geometric sequence. You have to recognize that it would be a geometric sequence given the nature of the situation. So this question here says the initial population of rabbits on the farm was 50. The population increased by 7% each week. How many rabbits were present after 15 weeks? This kind of thing here, so if we look at A, so the population is increasing by 7% each week. How would we increase the number by 7%? What would we do to it? Find the decimal multiplier. What would the decimal multiplier be for increasing something by 7%? Increasing by 7%. 1.07. Yes, we happy? So we would multiply something by 1.07 to increase it. So let's just go from basics here, because this is the whole nature of the thing. So if this was our initial population, to find how many rabbits we've got at week 1, we would multiply that by 1.07. Yeah? For week 2, we've already got this number of rabbits. We would multiply that by 1.07 again. And for week 3, we had our week 2 rabbits, and we're going to multiply that by 1.07. So obviously, well, I'm hoping that you recognize that this is now a geometric sequence, in that to get from term to term, we are multiplying always by 1.07. It does tend to be, for application of geometric sequences, that whilst we know that the term formula is u1 multiplied by r to the n minus 1, for application questions, it may be easier to think of it as un equals u1 just multiplied by n. You know how we were saying the other day about when we do the car value for the arithmetic sequence, and that the initial value was u0? It's the same kind of situation here. So you have a choice. You can either recognize that 50 is not u1, it's actually u0, or you now think of this as your formula rather than, and this is your initial value. Oh my gosh, it's so out. So that would be your initial value, you just multiply by r to the n. You happy with that? Yeah? Yeah? So week 1 would be our 50 multiplied by 1.07, so we wouldn't have to subtract 1 from it because that tells us our week 1, bless you, because C3 we're looking at the initial value here, okay? So if we want how many rabbits were present after 15 weeks, we would have, so 15 weeks would actually be 50 multiplied by 1.07 to the power of 15. You good with that? Yeah. So it just means that you do actually have to stop and think a little bit when it is situations like this, when they're talking about initial values. I have no idea what that number is, FYI. So I'm actually not going to look out.
137. You wanted to
360.
360. So 138.
Actually, tell me in decimals. 137.95. Okay, so here's the situation. You know what I was saying the other day is how many rabbits are actually present? Well, there's only a 0.95 rabbit. So we haven't got that rabbit. So really, our answer should be 137. Make sense? Yeah. Because whilst it's like someone having a baby, right? So they're really pregnant, but the baby's not there yet. So like whilst it's 0.95 but being grown, it's not actually there. So unless it's actually there, you can't say it's a rabbit. There's that number of rabbits. So whilst this number would normally round up to 138, you haven't quite got there yet. So therefore you can't include it. Yeah. Yeah. Makes sense. For what was the other number? I just moved it. 30 weeks. So it's going to be the same situation. So it's 50 multiplied by 1.07 to the 30. 80. How long would it take the population to reach 500? So this is where we're trying to find the value of n. So this is b. So we want a population of 500. So we're going to say 50 multiplied by 1.07 to the power n is equal to 500. What's the first thing we need to do here?
Maybe you should
Yeah, so we're going to try and get rid of that 50 because that isn't raised to the power. So we're going to divide both sides by 50. So we get 1.07 to the n is 500 over 50, which is now, as I said, if you did logs before and you remember how to solve these things, you can go for gold and try your log method. Otherwise, because we haven't learned logs yet or we haven't revised it yet, just guess and check. So chuck a number in, see which one gets you as close to 10 as possible. Now, what do we have to say? It has to reach 500, so we do have to make sure that it is more than 10, not close to 10. Now, here's a clue. Like, whilst we're guessing and checking, 30 weeks was 380 rabbits. So your value is going to be more than 30. So there's a tip for you. Yeah? You're trying to get to 10. You're trying to get this to 10. So 1.07 to a power, you want 10.
I got 10.6.
Try a couple of numbers less than that. Just
You'll have to
in
use
case.
actually power 34. Yeah, I did
34?
logs.
You did logs and you got 34.
Yeah.
Right, as I said, I will be recapping the log method because that takes a real long time.
Yeah.
Okay, we good with that though? Yep, we trace the hands. Oh, maybe we should do a stop. Oh, look at this.
Down, down,